Hello everyone, I'm Mr. McBrien, and this is TEJ3E, Circuits 2, Basic Circuits. Okay, yesterday we talked a little bit about an introduction to circuits and a bit about power. Today we'll do some more of the basic parts of circuits, talk about power calculations again briefly, and then talk about Ohm's Law and some definitions around those things. Okay, so we defined power yesterday. We talked about it being an amount of energy consumed per unit time. And the units of power are watts. We can calculate power by simply taking the product of the voltage, of the potential, times the current. So V times I is equal to the power. But we actually didn't really define those things yesterday. We didn't define the potential. We didn't define the current. So we'll do that today. Okay, so when we talk about potential difference, we want to talk about a battery or a power supply providing a force to push the current around the circuit. So, more accurately, interestingly, it is a force to pull electrons around the circuit. But either way, we can look at it in those terms. So this force, we call it potential difference or potential. The units of potential are volts, and when we apply a potential, we'll often say we're applying a voltage. So a symbol for DC voltage, DC potential, or for a battery is just this series of small, alternating small and large lines. And the longer of the two lines is considered to be the positive terminal of the battery, and the shorter of the two lines is considered to be the negative terminal. Now, the other aspect of our power equation was I for current. Current is the speed at which electricity is moving, the speed at which the electrons are moving. And it's measured in amperes, sometimes called amps. Usually of course, symbol doesn't have a, current doesn't have a symbol like other aspects of the circuit do, and this is because we can't really see current directly. But we'll sometimes show it as an arrow going from positive to negative in our circuit. And we'll see that arrow in a few seconds when we do some calculations. Okay, another important term in our current is in our circuit is resistance. Now, any circuit that isn't a short circuit will resist the flow of electricity. It'll resist the movement of electrons. And that resistance can be looked at based on the work done by a device in the circuit, like a motor, or it can be just calculated based on the type of material. Resistance, though, is measured in ohms and has the symbol of the Greek letter omega. And in a circuit, its cartoon is usually shown as a zigzagging line. So anytime we see this sort of sawtooth symbol, we'll realize that that is a resistor in our circuit. Alright, once we know how to talk about resistance and potential and current, we can start to talk about Ohm's Law. there's really a very simple relationship between current, potential, and resistance. So the current is equal to the potential divided by the resistance. And if we want to rationalize this, we can say that the current goes up when the voltage goes up, and the current goes down when the resistance goes up. And so I equals V over R. And I know you've likely taken this before in science class, but it's extremely important for the rest of the unit that we understand Ohm's law. So we're going to do some calculations here just to practice again. And in fact, your homework for today is a worksheet around this. So the kinds of questions that you'll see on the quiz are like this. What's the current in a circuit with a 200 ohm resistor and a 9 volt potential? So a very reasonable kind of circuit. And we can see the cartoon of it here, the schematic, with our 9 volt battery and our 200 ohm bulb. So we can do our calculation. Remember, for Ohm's law, I equals V over R. So V is the potential, 9 volts. The resistance, R, is 200 ohms. And 9 over 200, if we put it in our calculator, I equals 0.045 amps. Now we can also do 3 other forms of these calculations, of course. We can see a question, what voltage is required to get 0.02 amps of current with a 1000 ohm resistor? So in this case, we can see our current. We're given our current, represented by the arrow here, and we're given our resistance, and the question is, what voltage do we need to achieve that? Okay, well, we rearrange our equation. So V equals IR. Substitute in I is 0.20 amps. R is 1000 ohms. Put it in our calculator, and we see that we need a 20 volt battery in order to see 0.20 amps when we have a 1000 ohm resistor. Okay, the other type of calculation we can see is this kind of calculation, where we know the voltage, we know the current, and we want to know the resistance. So this kind of question will sound like this. If a 12 volt battery gives us 0.1 amps of current, what's the resistance of the circuit? And again, we rearrange our equation. The resistance is equal to voltage divided by the current. Then we substitute in our voltage, 12 volts, and substitute in our current, 0.1 amps. And then our trusty calculator gives us the answer. The resistance will be 120 ohms. So all these calculations will take this kind of form. So before you get to the homework, let's quickly summarize. Potential is the force that pushes electrons through the circuit, and it's measured in volts. Current is the speed of movement of electrons around the circuit, and it's measured in amperes. And the difficulty electrons have moving through the circuit, we call the resistance. It's measured in ohms. And we can relate these 3 numbers to each other through Ohm's law, which states that the product of the current and the resistance is the potential, or V equals I times R. Okay, that's all for today. For your homework, please work through the Ohm's Law worksheet, and we'll see you back here again tomorrow. Thanks for your time.